Well, hello and good morning. It's October 26th, and it's a little late in the morning for me to get going. But here I am looking at this radio again. So, the last video I posted, I titled it Failed Strategy, and that's exactly what it was. The strategy was figure out what somebody did to this radio before me, and then with that information and knowledge, proceed forward. Knowing what all's happened to this radio. That failed because I couldn't sort out what has been done to this radio. Well, you watched the video, you know what happened there. So I have a new strategy. So I've abandoned that strategy. My new strategy is get some work done. Start replacing these capacitors one at a time, and with each one, examine the circuit, examine the radio, examine the information, draw a conclusion about what it is, why it's there. Is it an original capacitor, or is it something part of a change? And just go through them one at a time. I have to do that anyway. Eventually I have to go through them one at a time anyhow. I just thought it would be an easy thing to sort out what was done to the radio previously, but no. Okay, so the name of the game now is who goes first, who goes second. And there's a guy in there, there's a capacitor in there with his hand up. This guy here, it's a big one. So I think we'll focus first on this particular one. I believe I identified what it was previously, but I'm going to do it all again. So we're going to start by recognizing that this guy is grounded to the chassis on one side, the negative side. The positive side is on the bottom terminal of the resistor. I'm going to hunt through the schematic once again, and I remember what that was. This is the output capacitor from the pi filter of the power supply. And it's an 8 on the schematic, it's a 10 here. So that's an easy one to replace. Now the objective here is, I didn't say this part, there is a hum in this radio. Somehow I sort of thought maybe it was attached to the idea that these wires have been removed and something else has been done, and the something else is just not able to eliminate the hum. But in any case, as I go through this, and I do especially these big electrolytic ones, I would check the radio for hum afterwards and see if some improvement has been made. Maybe we really need to start off by hearing that hum. Because we should hear the hum for what it is right now, and then carry on with. I'm certainly going to start with this one here. Let's do that. Let's turn on this guy. Okay, here we go. Oh, hear it? What's something kind of weird here? All these lights didn't come on. Haven't they been coming on all the time? Maybe those lights are burned out. I guess maybe they've never come on. Hum was strong at first. Hum is reduced. And it's continuing to go down. And I could do the parallel capacitor thing here. Just pop in to temporarily parallel, say a 10 in here, and see what happens to the hum. But I have to replace it anyway. What I'm interested in is, does this hum really disappear after a while? Doesn't seem to be the case. Let's just check tuning a little bit here. The hum is consistent all the time. The speaker's out of a cabinet right now, so the hum is actually not as strong as it would be if you put this into a proper cabinet. Band change. Tone change. Incidentally, one of you sent me an email pointing out an error on the schematic with the tone control. Maybe we'll take a peek at that if I remember. So the hum remains the whole time. And if we switch bands, wait a minute. This is the tone control here. More hum. less hum. You won't be able to hear this unless you're wearing headphones or have a very good system in your own house. It's a very low hum. Less, more. This is the band switch. The hum is always there. Nothing is changing it at all. Okay, I've heard the hum. I have the hum. We'll go after this capacitor and see what happens. And maybe for the sake of this video, I should just pop it up on the screen on the schematic here. So the capacitor we're looking at is this one right here, which is an 8, which is tied to the top of the resistor stack, if I can call it that. The resistor that's mounted on the back of the radio. The one that has 1, 2, 3, 4, 5, or 1, 2, 3, 4 different resistors in it. It's only showing 3. it just never ends. Oh, this is only showing 3. One. So 1 resistor, 2 resistors, 3 resistors, 4. 500, 8,000, I don't know what that is, 5,000, 10,000. 4 resistors. Oh, thank God, it's a coffee break time. What's happening here? So wire off of each one of these connections. This one's grounded. A wire off each one of them. 4 resistors, 5 connections. Shh, quiet. You're beeping too much. 3 resistors. Oh my gosh, I can't get even 2 seconds into this thing without something coming up and going, hey, you don't know what's going on. You don't know what's going on. Okay, let's look back. 10, 3, 5. Where's the little 500? What happened to the little 500? Down here. The little 500. But why does nothing match up? Oh my God, did the person who last worked on this radio come into this kind of conflict in these documents and would just plow their way through it? And is that why things are the way they are? So we're looking at, oh, my mouse is stalled, here we are. C34 and C16. C38. Okay, I've been down that road before. Well, I don't know what to say about this. Don't say anything right now. The 500 piece is missing at the bottom here. You know what else? I'll tell you what else. Let's look at the radio. Here's what else. Didn't I comment that one of these was grounded? No, maybe not. No, doesn't look that way. Okay, so, well, there we are. Well, I won't be too paralyzed here. I can change this out. We'll do that. First thing I will do, I'm going to nip it out of here. Read it carefully. Made in the US. Philco. That's very odd. Philco. I'm going to test the capacitance of this capacitor. I'm going to use this instrument. And I know from my experience with this, what I believe I should say is, if the capacitor is leaky, these instruments have a hard time determining their capacitance. They usually tend to show it higher than it actually is. 14 microfarads. Well, that doesn't sound so bad, does it? 14, and it's supposed to be at 10, so it's measuring high. tricky to determine the condition of these kinds of capacitors here, because they're leaky from the start. Especially the old guys. The old capacitors were so bad. If they're going to sell a 10, they're going to make it as a 20. They're going to manufacture a 20 and put 10 on it, and then they're guaranteed that it'll be at least 10 when it gets to the person who's going to buy it. So back in the old days, these capacitors were, there's nothing precise about the values on them. Okay, so this guy goes right with it, I think. There should be a capacitor essentially paralleling the one that was in here. A small, what was it? I can't remember, 0.02 or 0.05 or something like that. So there's a wire. There's lots of wires coming from this terminal here. One of them attaches here. Not that one. Oh, it could be a chain of wires. It is. Is it? Is it? No, it is not. Oh my gosh, I'm back into just chasing wires around again. I thought I was going to avoid that. Tell you what I'm going to do. I'm going to go I'm going to heed my coffee alarm and drink some coffee at this point. Okay, so I've installed two small capacitors in parallel here. There's two of them, for a total of 14 microfarads, quite a bit more than called for. I think 8 is what it's calling for, so I'm getting close to doubling it here. I don't think it's going to cause a problem. I think the problem was building bigger capacitors back in the day was very expensive, so they just wanted to go for the smallest capacitor they can get away with all the time. A little bigger won't hurt. Really big might hurt. Okay, so I think we're ready to switch this on. Here we go. I switched it off, didn't I? I unplugged it. That's what I did. Okay, here we go. This time for real. Ooh. So that hum comes in pretty strong at first. It scared me. So this has had no effect on the hum. See, what I suspect is there's an error in this radio somewhere, and that's why it's humming. And goodness knows, you know, in the combination of the schematic and the other diagram and this thing, it would be pretty easy to make a mistake, which is what I'm trying to avoid. Okay, well, here it is again. Very good. That's good enough. That's good enough for now. Okay. No hum gone on one capacitor yet. So what? That's not even English. Is that even a sentence? You know what the problem is? The problem is I made a cup of coffee, but I haven't drank any of it yet. So I gotta go deal with that. Okay, let's try another. Excuse me. Now there's another electrolytic excuse me, capacitor hidden in behind here. And you can see the number 8 written on it. I'm pretty sure that's the size. One lead comes out here, and the other lead is coming out to here. Don't touch the radio when it's plugged in. That's my rule. Okay. So between here and here, and I could check this yesterday, I could see the leads, and in parallel with that is this resistor here that measured 5,000 ohms. It was right on the money. So that combined is a bypassed cathode resistor. And the bypass capacitors back here. It's a big one. Let's take a look on the schematic at this point. So the capacitor we're talking about is sitting right here. Zoom in a little bit. So if you follow this line up, we end up on the cathode. So the cathode current is flowing through this resistor, causing a voltage drop, making the cathode go a little bit positive, and that's what's developing the relative negative bias of the grid, making the cathode positive. But you really want a signal ground on the cathode, so you bypass this resistor so the signal sees the ground, and use a big capacitor. It's a 4, but in the radio is an 8. It's just another little unnerving change to, in the radio itself versus the schematic here. And let's just, yeah, there's no values on here, is there? It's just just the label for the part. Okay, well, I'm going to replace it. Probably put a 4 in there. Why would I want to put an 8? Let's cut the one out that's in there right now. Hidden away in behind. Absolutely sure of what I'm cutting. Yeah. Need the light to see it. Oops, I think we'll come out this way. Eight microfarads, 200 volts. 200 volts. That's a unnecessarily high rating there. Positive this way. Okay, why don't we test this? Because I can't find my tester. So that's why we don't test it. What did I do with it? Right in front of me here? Oh my gosh. Yeah, it is. It's right in front of me. So I know a lot of people make videos these days where if they hesitate for a fraction of a second between words, they go back and edit out the hesitation. Have you noticed I don't do that? No, I'm not doing that. $12 nanofarads. V loss 32%. Wow, I don't know, this guy's not testing well at all. It's horrible. Well, maybe we found something here. Okay, surely 4 is enough. I'm going to put a 4, or maybe I'll go all the way to a 5 and stick it in here, and then we will test the radio again and see if I found the hummer. Maybe this time I did. Okay, I think we're ready for another test. Now the capacitor I took out that big, and the one I put in is one of these little guys here. You can hardly see it, it's right there. That's a 10. I put in a 10. An 8 was in there. The schematic calls for 4. I'm putting in a 10. I'll show this radio who's boss. Okay, ready for another test. It's time to plug it in. Double checking to make sure I got the polarity correct. I don't think I have the polarity correct. Oh my gosh, how dozy can you get? Let me just... Oh, no, looks good. Oh, no, got it backwards. Oh my gosh, it's just unbelievable. Yeah, that's kind of par for my course. I have this way of getting these in backwards all the time. And, you know, it's a skill I've been developing over the years. Not everybody can do this. I can't believe I got this backwards. Yes, I can. That's why you saw me check it so carefully. Great big terminals here that take a month to heat up. There we go. Come on out of there. Oh, that would have been exciting had I turned this on. That could have been very, very exciting. Let's see if I can just fit it in here like this. No. We must put the pliers to it. I've said before, I usually, when I make a mistake like that, I usually spend a little bit of time considering, how did I make this error? Part of it is I'm getting older. I think that's part of it. Yeah, this isn't going to go well. Yeah, getting older. I've been getting older my entire life. I don't know how it's going for you, but there, that's better. Down a little bit. Hang on there. I noticed this when I was around 10 or 12. I was like, hey, those old people, you know, the 17-year-olds, they don't look so old anymore. What's happening? That's carried on all my life too. When I first started in my job, I had a partner who was close to retirement. So I was a young guy working with a nearly retired guy. And he wanted to, you know, I don't know. He was very kind. He was a very, very kind guy. We're out in our truck driving up Yonge Street in Toronto. Yonge Street is a very famous commercial street, kind of the core of Toronto to some degree. You could think of it that way, I guess. And we're driving up the street, and of course I'm 20, 21, I'm looking out the window, I'm looking at the girls on the street. And he notices those girls too, and he's looking at them. And I looked over at him and I said, you're too old to be looking at young girls like that. And I said, Jim, I'll tell you something. When you get older, the young girls still look good, and the old ones start looking good too. And I just thought this was the most optimistic view. I've tried to follow suit, not on that particular note, but on other things. Getting older comes with some benefits. I don't know what they are. I'm trying to find them, but yeah. Okay. Including, you know, when you get older, you get wise enough to accept the fact that you may have made a mistake, even anticipate your mistakes. And the great thing is, you can forgive yourself of those mistakes when you get older. Of course, there are some mistakes you cannot afford to make. You know, threat to your life and things like that. There we are. Okay, this time, can we turn this on? Once again, I am looking at it, making sure the negative is here, which it is. Well, I came pretty close to getting that in backwards. Not a lot of voltage here anyway, so probably the capacitor would have sat there and nothing would have happened. That's probably the situation. And I wouldn't have known my mistake, but somewhere down the road that capacitor would probably give up the ghost. I don't really know. What happens if you reverse the polarity on a capacitor with a low voltage? Can't be good for it. Okay, we're ready again. Ready for another test. This time I'm going to be bold enough to actually turn the power on. Here we go. There's the hum. It came right in. Hum comes in, think about this, doesn't come in the moment I hit the switch. It comes in a moment later. What happens a moment later? Well, what's happening in that little window where there's no hum? Well, maybe you can't hear the hum because the speaker's not working. The speaker can't work until there's current in this coil. There could be a hum on the voice coil right from the start, and you wouldn't hear it. But we do hear it. We do hear it. No, we don't. We don't hear it for the first fraction of a second. It's probably what it is. Probably the field coil comes to life, and then the speaker can operate. So the hum is probably there from the instant we turn it on. We just can't hear it. And it's still there. And the radio's working. And the capacitor did not explode. Okay, there's a chance I will replace the remaining capacitors, 1, 2, 3, 4, 5, 6 or 7 or 8 or 9 or 10 capacitors, and this thing will still be humming exactly as it is. But I think this is a better strategy. I'm getting something done. I'm going to find out each part as I do it so I can relate it back to the schematic and sort out if there's something weird. When I get there, I can deal with it. There's actually a lot of capacitors in here. 1, 2, 3, 4, 5, 6, 7, 8. Could be another one in behind the plate. I don't think so. 8. And I bet you there's another one in there somewhere. 9. Okay. Well, we'll just plug along day by day. Take a few each day and see if we can't discover where the hum's coming from. Very good. Feel a little better today because I actually got something done. Thanks a lot for watching, and slow and steady wins the race. That's I'm sure you've heard that before. See ya.